Great answer, Dr. Lau. Uh, my next question would be, and it's an exciting one, and I believe will lead into some solid follow-up questions and discussions. What would you say are some of the best lines of evidence against an old universe and for a young one, Dr. Lau?
The best ones, we have the birth certificate of the universe. The Bible is a history book that records when the universe began. In the beginning, God created the heaven and the earth. Human beings are made on the sixth day, and from adding up those genealogies and so beget so-and-so. You find that it's about 4,000 years between Adam and Christ's earthly ministry, which was about 2,000 years ago. So something like 6,000 years. That's the best evidence because it's recorded history. Now, I think there are lines of scientific evidence that confirm that history, that confirm a recent time scale. But that's the best because it's history, right? I mean, if you want to find out when the last World War happened, you read a history book. You don't do a science experiment and mix chemicals. It might confirm that, but the best way to answer a history question is with a history book. That being said, I think there are a lot of lines of evidence that confirm that. Lots of stuff in space. That's, of course, my area of expertise. There are things that can't last billions of years. Comets, for example, they can't last even millions of years, really, because a comet is made up of ice and dirt, and it orbits the sun in an elliptical path. And when it comes close to the sun, that icy material is blasted out into space. That's what forms a comet's tail. We had a really nice one this last summer, actually. I hope you got to see it. Nice naked eye comet. It was very beautiful. But every time you see a comet, it's getting smaller. It's losing mass. We can calculate the amount of material that's there. We can calculate the rate at which it's being depleted. They can't last millions of years. 100,000 years maximum for a typical comet. In fact, in my doctoral research, I used the SOHO spacecraft, and it looks right at the sun. And one of the instruments on it blocks the sun and looks at things that get real close to the sun, like comets. And I've seen comets that have gone behind the sun and been totally destroyed in one pass. So they don't last millions of years. And my secular colleagues don't even dispute that. They would say that there must be some kind of source of new comets. They call them Oort cloud. There's no evidence for that in our solar system in terms of observational evidence. Lots of things like that. The rate at which magnetic fields decay. Magnetic fields don't last millions of years. Magnetic fields are caused by electrical current in the core of a planet like the Earth, and that has been decaying. We know Earth's magnetic field's been decaying. We've been able to measure it for the last almost 2 centuries. It's definitely decaying. It seems to be an exponential decay, which is what we would expect on first principles. It's not oscillating, not today anyway. It might have during the flood, but other planets as well. There's evidence that Mercury's magnetic field's decaying. Jupiter has an enormous magnetic field. They don't last millions of years. With Earth's magnetic field, based on the current rate of exponential decay, you run it back 60,000 years ago, it would have been stronger than a neutron star, which is enough to rip the atoms of your body apart. And so it can't be anywhere near that old. It's not even a million years. It can't be anywhere near that old. Or carbon dating. A lot of times people think carbon dating gives the millions of years. It doesn't. Now all these dating methods are based on certain assumptions, but the fact is a lot of them give ages. Even if you assume secular principles of uniformitarianism and naturalism, a lot of them still give ages much less than the billions of years, including the fact that C14 has been found in things like diamonds that are buried deep down in layers of the Earth that are well insulated from cosmic rays. C14 doesn't last even a million years. It decays very quickly. And so the fact that you find it in fossils and in just about everything that has carbon in it is a strong indication that the Earth is not anywhere near billions of years old. Lots of stuff like that.
Wow, that's a great response. A lot of good information there, Dr. Lau. With the comets one, for example, that limits the age of the universe, I've seen, as you pointed out, this Oort cloud that's constantly being invoked. But like you said, this Oort cloud is not actually based on real, observable, empirical evidence. Is that right, Dr. Lau?
Yeah, I mean, it's the idea is with an Oort cloud and it's named after Jan Oort, the guy who came up with the idea. The idea is that there's a vast supply of potential comets out beyond the farthest planets, out way beyond Neptune, but we couldn't possibly detect them at that distance. There's no way to detect them. So it really seems to be a rescuing device, a hypothesis that the secularists have invoked to protect their worldview from what appears to be evidence to the contrary. And they'll say, well, you can't disprove an Oort cloud. And that's true, I can't. It's undetectable. But there's no evidence for it either. They'll say, well, we find evidence of Oort clouds in other solar systems. Not really. We do find solar systems that have some kind of debris orbiting them, but we don't know that it's billions or trillions of comet nuclei. And even if you did find an Oort cloud, there's a problem in how would you make it under naturalistic assumptions. The idea is that some of those have been flung out. Maybe Jupiter flung some of the original ice in the solar system out to the extremities, but the simulations I've seen of that don't get nearly enough of them out there to make an Oort cloud. So it's problematic if it's there, and it's problematic if it's not there. But since there's no evidence for it, I presume it's not there.
Right. Great response. I've even seen a lack of confidence sometimes in the response from the uniformitarians and the evolutionists with the Oort cloud. So great response. Great response. So the next question then is a very common one, especially for you, I'm sure, Dr. Lisle. I want to first say great job in your latest informal debate with Dr. Hugh Ross.
Thank you.
I think I can speak for everybody when I say you really demonstrated just how scientific the young Earth creation model is. Now, the topic of distant starlight was brought up in that debate, and you gave some really great responses that I believe were not well countered or responded to. So my question would be this: given the biblical timescale that God created the universe roughly 6,000 years ago, how are we able to see stars and galaxies that are billions of light years away?
There's more than one way God could have done it. The method I think that he used doesn't involve any kind of supernatural activity at all. Of course, God can do miracles. That's not a problem for God. So we dare not say, well, I don't understand how you could have done that, God, therefore you didn't do it. Well, that's absurd. I mean, you'd have to eliminate the resurrection and turning water into wine and all these things. But the way that I think that God got the light here is I think that the Bible is using a synchrony convention that's different from our modern synchrony convention. Now, what's a synchrony convention? That's the idea that two clocks separated by distance are synchronized. Well, how do you decide if two clocks separated by distance are synchronized? Now, if the distance is short, it's pretty easy. You just look at them and you say, well, they're both synchronized. But if light takes some time to get from that clock to your eyes, then that might be a little bit of a problem. They might look synchronized, but in fact, one of them's a little bit of ahead of the other, but it took more time for the light to get from one than the other. So you see, it becomes a little bit of an issue when the clocks become separated by cosmic distances. And it turns out, this is something that Einstein wrote about, it turns out that there is no objective way to synchronize two clocks separated by a cosmic distance without assuming the speed of light in one direction. And when I mean the speed of light in one direction, most of the experiments that have been done to measure the speed of light involve either directly or indirectly a two-way trip. It's like you're taking light from a source, you're sending it out, bouncing it off a mirror and bringing it back, and you're measuring the total time, the total distance, and you divide the distance by the time. That gets the average velocity. And a lot of times people assume that it takes the light the same time to go that way as it does to go that way. We don't really know that. And in fact, according to Einstein, it's impossible to know that. And people say, why would it be different in different directions? Well, I don't know, but there's no reason why it would have to be the same either. And I found the concept's a little bit difficult for laymen to grasp because it takes a little bit of knowledge of the physics of Einstein. And so I actually wrote a book about this topic called The Physics of Einstein, where it brings people up to speed on the physics that they would have to know in order to recognize why you can't actually objectively measure the one-way speed of light, because you'd need two clocks that are exactly synchronized, and there is no objective way to do that in the universe. There are subjective ways to do it, where you can say, I'm going to call this synchronized, and somebody else is free to disagree and say, no, I don't think they're synchronized. I think they'd be synchronized if this one was turned a little bit ahead of that one, so that now they're synchronized. And the bottom line is, if you use the ancient method of synchronizing clocks, which is a visual synchrony convention, clocks are synchronized if they look like they're synchronized, basically, then light takes no time at all, even today, to get from those distant galaxies to the Earth. And so it can actually arrive instantaneously. And that doesn't violate any physics. It's actually perfectly consistent with the physics that Einstein discovered. It's just that a lot of people don't know about it. And I know that's a little bit abstract. I found that it takes probably at least 20 minutes really to bring people up to speed on the basic issues so that they can comprehend the thrust of the argument. But I do have a series of articles on our website at biblicalscienceinstitute.com. Our latest articles are on this very issue. I've been bringing people up to speed on the starlight issue, some of the other solutions that have been proposed, and why I think this, what I call the anisotropic synchrony convention, is the best method. It's consistent with the physics of Einstein. Nobody can disprove it. It makes sense historically. And in that model, light can get from the farthest galaxy to the Earth immediately. It takes no time at all. And therefore, there is no distant starlight if you understand physics.
Awesome. That was a great answer. Matter of fact, even going back to your debate 2 months ago with Hugh Ross, he objected that your distant starlight argument by asking, when we look at the sun, do we see the sun as it is now or as it was 8 minutes ago? Right. So it appeared that by asking that question, Hugh Ross didn't fully understand the physics of Einstein. Now, what would be the best response or argument to that specifically?
Yeah. When he asks, is it this or that? It's like asking, is a table 3 feet long or is it 1 yard long? And of course, the answer is both. It depends on what units you choose to make the measurement with. And so whenever anybody asks that question, does it take light 8 minutes to get from the sun to the earth, or does it get here instantaneously, or 16 minutes? And the answer is it depends on the synchrony convention that you choose. There is no objective answer to that question. People get frustrated because most of us have a view of time that it's sort of absolute and universal. It's the same everywhere. Clocks all tick at the same rate. Everything, you don't have to worry about these synchrony problems. But Einstein discovered that is not the case. Time is not the universal objective thing we think it is. It's affected by motion, gravity, and things like that. And so the amount of time it takes light to get from A to B and back to A, that's objective. And that time is objective, and there's no getting around that. The round trip speed of light is set by God in vacuum. You can't change it. But the one-way speed depends on how you choose to synchronize clocks. And so does light take 8 minutes to get from the sun to the earth, or does it take no time at all? The answer is yes. And the same is true for distant stars. Does it take years for their light to get here, or does it arrive here instantaneously? The answer is yes. It depends on which synchrony convention you use. And I believe the Bible's using the more ancient synchrony convention, in which the celestial events are marked by when you see them. And so in using that system, God created the entire universe. The light was immediately visible to Earth on day 4, as soon as God created the luminaries. And that gets around a lot of these other issues too of, people saying, well, God made the light already on its way. Well, then he's making pictures of things that don't exist. This gets around all that, because all the stars that we have pictures of really existed in real time. It's just that we see them immediately.
Oh, I love it. Great answer. We've got a lively chat who are really enjoying this, and who really enjoyed your debate with Hugh Ross a couple months ago, and share my opinions with it. Here we've got Tony Torpa. Question came in. Hi, Jason. Has anything been heard from Hugh Ross when you challenged him to read your article, Distant Starlight and ASC, in your last debate? Thanks for your new posts on the subject. They are awesome.
Thank you for that. No, I haven't heard from Hugh Ross. I hope that he did look at that article, because he was under the mistaken impression that light from a supernova could be used to measure the one-way speed of light. It cannot. And I had already answered that, because there was a critic named Peter who had posted that same thing. And I demonstrated that, in fact, Peter had made the assumption in his question that the speed of light's the same in all directions. Otherwise, his question wouldn't make any sense. The fact is, you get exactly the same answer for when you see the light from a supernova that's been gravitationally bent. You get exactly the same answer, whether the light in one direction is instantaneous, or whether it's C, or whether it's any other value that's allowed. And the reason for that is light can only be instantaneous in one direction relative to a given observer. And so the light from the supernova would have to go at an angle. And so it wouldn't be quite instantaneous when it first goes out, until it gets bent around the galaxy and then zips directly toward the observer. And so I answered that, and Hugh hasn't got back with me yet. I hope he will. If he wants to, if he thinks I'm wrong, he's welcome to challenge me, and I'd be happy to post his reply and my reply to his reply, and so on.
Awesome. Yeah, great response. I mean, it looks like oftentimes I find that the critics, even some of the most militant critics, just aren't really up to date on the literature on this anyways. Yeah. So I guess you kind of answered this, but a question would be, how do you feel the critics have responded to your arguments overall, Dr. Lisle, on distant starlight in a young universe? For example, as you're covering here, the one-way speed of light and synchrony conventions. In other words, have they provided any sufficient rebuttals? And if possible, and you did cover a couple here, what are the best possible responses to those rebuttals?
I haven't seen any serious rebuttals, to be honest with you. People who are physicists and are trained in relativity have, some of them have said, well, Lyle's right about that. So, and of course, some of the papers that promote an ask type model like the one by Sarkar and Stachel that I like to point out, and the authors are not creationists, but they agree that light can get here instantaneously using the correct synchrony convention. So I haven't seen any real. I've seen internet rebuttals by people who don't seem to be trained in relativity. I've seen one that says, well, no, you can't use that coordinate system where it would create a gravitational field, which we don't see. No, that's not the case. Switching coordinate systems does not create a gravitational field. You can measure things in polar coordinates. You can measure them in rectangular. You can measure using an Einstein synchrony convention or the anisotropic synchrony convention. It doesn't create any magnet or any gravitational fields. And anyway, it actually the most of the ones, if you go back a few months back on my website where I respond to Peter's objections on distant starlight, most of the ones that I've seen on the internet, he repeated those and I answered them. So I haven't seen any ones that are a serious challenge from a physics perspective, because frankly, the conventionality thesis upon which my model is based is really pretty well established. I consider it proved. John Winnie back in 1970 showed that all of special relativity can be done without the one-way speed of light, leaving it as a free parameter, which the epsilon, the Reichenbach epsilon. So I haven't seen any rebuttals at all, really, other than ones that are kind of on the internet, not peer-reviewed ones.
Right, you're going to get that with everybody, though. I mean, you
Sure.
see that everywhere. The internet,
Of course.
the internet's the criticism area. So here's one. You did answer at least the first part earlier, but I'm just going to read the entire thing for you because this was a critic question. So the objectum, for the sake of argument, let's accept that your claim for the round trip average speed of light is 186,000 miles per second. If this is true, and this is the one-way speed of light, then in order to accommodate a 6,000-year time frame, these specific critics have stated that there is no simply no reason to think that the one-way speed of light is over 700 times faster than the round trip speed of light.
Well, when people state things that way, that suggests to me that they're not understanding the physics of the situation. It'd be a little bit like saying the metric system is clearly the correct way to measure things, and not the English system of feet and inches. I mean, because 12 inches in a foot, I mean, that seems unlikely. Whereas meters, it's 10 centimeters, 100 centimeters in a meter, and so on. That's all 10. That's nice and neat. Nature clearly prefers metric over English. Well, no, it doesn't, because you see, when it comes to a convention of measurement, you can't use Occam's razors. Well, it's more likely to be this than that. No, it isn't. It's your choice. The English system, in terms of inches and feet and foot pounds and so on, it is a lot more complicated. It's hard to keep track of than the metric system. It is. That's why scientists, we like metric. And we do all our calculations in metric, and then if we need to convert at the end, we can. But that doesn't mean that English units are wrong. And it's the same way with the one-way speed of light. It's not that it's this or that or the other. It's what you choose it to be, and that will tell you how to synchronize two clocks that are separated by distance. And I know that's counterintuitive, but folks, if you're gonna if you're gonna argue on this principle, you need to get up to speed on the physics of this. This has been discussed. This topic of the one-way speed of light and its immeasurability has been discussed for over a century. There's a century worth of literature out there devoted to this topic. And not long ago, I came across a book somebody had written. Max Jammer wrote a wonderful book called Concepts of Simultaneity from Antiquity to Einstein and Beyond. And it's a nice summary of the scientific literature, written really pretty much at a layman level. And so that's a nice way to get up to speed on these issues. But when people say, well, it's more like the speed light's more likely to be this and than that, or there's no evidence that it's one way or the other. No. This is a convention of measurement. It's a convention by which we decide what we're going to call synchronized when we have two clocks separated by distance. That's all it is. And that's why there is leeway in terms of how you choose to set the one-way speed of light. It's not something that can ever be measured. It's because it's not an objective property of the universe. It's a human choice.
Right. That's a great response. These critics, like you said, Dr. Lisle, they need to get up to date on this. This physics, as you said, is known and it's understood. And it's probably why you have not had any convincing rebuttals. So that's a great response. This is awesome.
They feel that this one actually defeats biblical creation, as we know it won't. But multiple meteorites, moon rocks, and Martian rocks dated on location, all yield a consistent age of 4.6 billion years, plus or minus a few. This is true across a variety of locations, across a variety of different dating methods.
We don't.
How would you explain this?
We don't have any access for sure to anything from Mars by which we could date it. It's thought that some of the rocks that we collect on Earth that are meteorites may have originally been from Mars. I'm a little skeptical of that. We certainly don't know that's the case. We do have rocks from the moon, and those have been dated using the uranium lead, I believe, method, and perhaps others. And yeah, you do get ages of 4.5 billion years, which you don't get for Earth rocks. Interestingly, you don't get quite as old ages for Earth rocks. So, but the secular thinking is that Earth's been reworked by plate tectonics, and so you don't have original Earth rocks. They've all been reworked multiple times. What's the explanation for that? Well, we think that there's very compelling evidence that the rate at which radioactive decay has happened in the past has been accelerated, and that would account for why there tends to be a convergence on a particular age for rocks that are not Earth rocks. For Earth rocks, you get inconsistent ages. You can take an Earth rock and date it using one method and then date it using another method, and you get different answers. And this has been well documented. John Woodmarappy's book, The Mythology of Modern Dating Methods, documents published dates. These are ones that have been peer-reviewed. They're published in the peer-reviewed literature, to say nothing of the dates that were inconsistent and therefore never published. I mean, think about that. Think you're a secularist and you date a rock and it gets you an age that's way off what is expected to be for that formation. Probably you don't publish it. You say, well, obviously something went wrong there. And so the fact that you have inconsistent data, even within the literature that was published, suggests that there's a far greater number of inconsistencies that have not been published. The Rate Research Project, too, in their book, they also documented. There's a chapter on the discordant date. So it's not as consistent as you've been led to believe. Now, I do think it's a little more consistent for moon rocks because they haven't been reworked. There was no worldwide flood on the moon. And so whatever process God used to make the moon apparently was pretty uniform. And so even though the decay rates have been accelerated, there's good evidence for that. Read the rate research on that. Presumably it happened at a uniform rate. And so that's why you get some degree of consistency with moon rocks, but very little consistency with Earth rocks.
Yeah, there probably is some kind of maybe enhancement of the decay rates. For example, here's something. When they went to the moon and they got one of the first moon rocks and they brought it back, I forget the exact number of what they identified it as. Oh, here it is. Lunar sample 14321. It dated at 4 billion years old. But when they tested it, it was actually a piece of driftwood from Earth. But the oldest tree dated is 350 million years ago on Earth. So how could that even be a thing? I'm just curious if you ever heard about that or considered.
I haven't heard about that specific one. I have heard of examples of, for example, wood that's embedded inside rock. Volcano will come, uproot trees, lava will flow over it. So you have wood embedded in rock, and the rock dates to millions of years, and the wood dates to thousands of years. So that's a problem. And in case people are wondering, when you date a rock, it's supposed to tell you when the rock hardened. Because before that, everything's liquid. The minerals can move in and out. But when it solidifies, then that's supposed to trap the parent and daughter elements. And so the only way you get daughter elements is by the conversion of parent elements. And yet you get wild inconsistencies. So inconsistencies in radiometric dating is not new. It's well known. And we've taken rocks from Mount St. Helens, brand new rocks, sent them into secular labs to have them dated. You get hundreds of thousands of years on brand new rocks. So we know radiometric dating does not work on rocks of known age. It's assumed to work on rocks of unknown age. And I think that's not very scientific.
Yeah, matter of fact, you mentioned accelerated nuclear decay. So if this was occurring maybe during the flood or even during the creation event, would this have also made these dates unreliable?
Yeah, if you assume that the decay rate is constant, when in fact it was faster in the past, your ages will be inflated. And they'll be inflated by the degree to which you assumed that something was constant divided by the rate at which it was accelerated as a rough measurement. So if the decay rates were millions of times faster during the flood year, for example, and there's very compelling evidence for this, because the fact is when uranium, for example, when a uranium atom it decays into the next element, which decays into the next one, all the way down to lead-206. For every one uranium that turns into a lead-206, it emits, in that process of radioactive decay, it emits 8 helium nuclei. So it produces helium as a byproduct. And helium is a gas, and rocks are porous. And so gas can leak through rocks. And it doesn't take millions of years for that to happen. And so the bottom line is, if the rate at which the uranium turned into lead had always been the slow rate that it is today, that the helium that's produced would have had plenty of time to escape. There should be very little helium in these rocks. And the research team found that there's abundant helium trapped inside these rocks that have radioactive elements in them. And it's consistent with all of that decay having happened in the recent past, thousands of years ago. Now, there is a temperature dependence in terms of the rate at which the helium leaks through. But in order for it to accommodate the data in billions of years, the temperature would have been close to absolute zero, which is absurd because the temperature actually gets hotter as you go in toward the Earth, because the Earth has a molten core. So there's compelling evidence that the radioactive decay rates were much faster in the past. There's been this opinion in the last few decades, well, previous to the rate research and a few other research projects by secularists, actually, there was this opinion that radioactive decay rates cannot be influenced by any external parameters, because when you do chemical experiments, it tends not to affect the radioactive decay rate. But we now know that it's false. There are some ways of accelerating certain kinds of radioactive decay. For example, the rhenium-osmium reaction has been sped up in a laboratory by a factor of 1 billion. And all you have to do is strip away the electrons from the rhenium, and it will decay much, much more quickly. So, and that's one method. That's a method we can do. God obviously has options that we don't have. God could change the nuclear strong force by a bit, and that would change the rates of decay and so on. So there are different ways in which radioactive decay could be accelerated. We think there's good evidence that happened during the flood year, and that would explain why the secularists, not including that factor, get ages that are far older than the true age, including on things whose true age is known, because it happened in recorded history, for example.
Makes sense. Do you think that this accelerated nuclear decay would have caused what they deem as the heat problem? They said, this convection and the subduction plates would have caused so much heat generated during this nuclear process that the oceans would have boiled. Have you heard of this? Do you have an answer? Yes,
I've heard of that. Yes, I haven't seen a detailed study on that, other than there are ways to dump the heat. First of all, you need heat. You need heat to start the flood. So that's not a bug, that's a feature. To get the plates moving, they need energy, and an acceleration of radioactive decay, that's a great way to start plates moving, to heat them up to where they can be hot enough where they can be almost not quite a liquid state, but it makes them more malleable. Where did the heat go? Well, we don't know. First of all, we don't know what the Earth's temperature was in the core, for example, before the flood year. What if a lot of that energy is now, what if it's still there? What if it's still in the core? A lot of the energy could have gone into that. A lot of the energy could have been dumped to space. There have been creationist models of hypercanes, for example, which is like a hurricane, but on a much more massive scale. Hurricanes are very good at dumping heat, dumping energy to space. When a hurricane goes over the ocean's temperature drops by 10 degrees. And that's a piddly hurricane. Imagine a hypercane that's taking all this energy and dumping it into space. Convection is a great way to move heat quickly. It's the best way to do it. And we think there was a lot of convection during that flood year. So there probably were spots on the ocean, hot spots that boiled. There probably were. But as soon as they get to the air and they spray up, and then they lose that heat and so on, they lose it to space. So there are lots of ways of dumping the heat, and perhaps a lot of the heat is still in Earth's interior. Since we don't know what the original Earth's interior, we don't know how hot it was to begin with. Some of the energy could have gone there. There are other explanations for that. I don't have the numbers with me to see, which of these is the most plausible, but there are some possibilities right there. So certainly it's not a knockdown, drag-out argument against a accelerated decay because it produces heat. That's a feature. We need some heat to start the flood, and as long as you can dump it to space fast enough, you're going to be fine.
Right. That was a really good answer. Probably one of the best I've heard on that specific criticism from your critics that say there's an unsolvable heat problem. And I've seen you, Dr. Lisle, speak on accelerated decay quite a bit. I saw you brought up the helium and zircons in a debate you had with Dr. Ross, but this was one, I think, years ago where Frank Turek was moderating.
Mm-hmm.
And I wasn't exactly thrilled with Hugh's response. I think you got him on that one real good. And I guess you did kind of just answer this actually, but the question would be what are some of the best responses to critics who say, because I constantly hear them still continuously repeat this, even though you just gave a huge number of overwhelming lines of evidence suggesting accelerated nuclear decay has occurred, but they still say, nope, this isn't possible. It's never been observed in the lab. What's a good quick response to these critics who make that
Well, it has
claim?
been observed in the lab. There's no doubt about that. Have them look at the rhenium-osmium reaction.
Right.
Bound state beta decay. You can make that rhenium decay 1 billion times faster than it does in normal circumstances in nature. And granted, I'm not suggesting that that's the solution to all of them. I'm not suggesting that that all the material was ionized and things like that. But my point is, if you want to blow away this assumption, the assumption that radioactive decay rates are always constant is false. It's demonstrably false. That has been disproved in a laboratory. Now, that doesn't automatically mean that decay rates were faster in the past, but it does mean that that's a possibility. It's not something that can be dismissed out of hand. I do think the helium and the zircons is just, I don't know how secularists sleep at night with that data, because how do you explain that? In billions of years, there's been plenty of time for that helium to escape. We know the rate at which it leaks through rocks. That's been measured, and there's just no way you can make sense of that. I'm not an evidentialist, but at the same time, I don't see a good rescuing device even for that.
Right.
So I think the evidence is very compelling for accelerated decay, and in any case, we have tested radiometric dating on rocks of known age, and it often gives the wrong answer. So that immediately, as a scientist, just somebody being an objective scientist, you should say, we really shouldn't have a lot of confidence in that method because we know it gives wrong answers on dates of known age. So it doesn't make sense to trust it on dates of estimated ages for things whose origin is not known.
Right. I think you nail it with that, Dr. Lau, where you say we don't get accurate dates from rocks of known age, but yet they want us to trust the rocks of unknown age and the dates. It just seems common sense not to.
Yeah.
So, right.